My name is Rose Mary Hernan. Good day, everyone, and to those watching this video, good day. Now, let us begin with my presentation. My first topic is about the normal curve. The normal curve was developed mathematically in 1733 by de Moivre as an approximation to the binomial distribution. His paper was not discovered until 1924 by Carl Pearson. Laplace used the normal curve in 1783 to describe the distribution of errors. Subsequently, Gauss used the normal curve to analyze astronomical data in 1809. The normal curve is often called the Gaussian distribution. The term bell-shaped curve is often used in everyday usage. The normal curve is a symmetrical distribution of scores with an equal number of scores above and below the midpoint of the abscissa. If we say abscissa, it is the horizontal or the x-axis of the curve. Now let us proceed on the standard normal distribution or the Z distribution. A normal distribution with a mean of 0 and a standard deviation of 1. Here's the example of standard normal distribution. As you can see, the mean here is 0 and the standard deviation here is 1. By using this formula, Z equals X minus mean is a result of a standard normal distribution or the Z distribution. For example, as you can see, the value of X is 1 and the value of mean is 0. By computing the value of the Z distribution, we can simply distribute the value of X, which is the 1, and the value of mean is 0. And simply subtract 1 to 0, and the answer is 1. Now, the value of our Z distribution is 1. Now, let us proceed to Z-scores. So, what is Z-scores? Hopkins and Stanley, 1981, page 52, defined standard scores as scores expressed in terms of a standard, constant mean, and a standard, constant standard deviation. How to calculate a Z-score? To standardize a value from a normal distribution, convert the individual value into a Z-score. First, we are going to subtract the mean from your individual value, and second, divide the difference by the standard deviation. So, these are the formula by computing our Z-score, which is X is our individual value, and the symbol of mean and the symbol of standard deviation. Now, let us proceed to T-scores. So, what is T-scores? T-scores are standardized scores on each dimension for each type. Stannin defined descriptively with percent of scores. So, what is Stannin? A Stannin is a type of scale score used in many norm reference standardized tests. So, let us proceed to coefficient of variation. The coefficient of variation, or CV, also known as a relative variability, equals the standard deviation divided by the mean. It can be expressed either as a fraction or a percent. The coefficient of variation, when described as a percentage and calculated from the average and standard deviation as follows. So, by computing the value of coefficient variation, we are simply use this formula which is standard deviation over mean times 100%. So if we have a given number, so we have simply substitute the given number and we can find the value of our coefficient variation. So next, interpreting test results. So there are two main groups of interpreting test results. The first group is criterion reference assessments, and second one, the norm reference assessments. If we say criterion reference assessment is a test or a type of assessment designed to provide a measure of performance that is interpretable in terms of a clearly defined and delimited domain of learning tasks. Criterion reference assessment, these include checklists, rating scales, grades, rubrics, and percent accurate. If we say norm reference assessment, it is a test or other type of assessment designed to provide a measure of performance that is interpretable in terms of an individual's relative standing in some known group. Percentile ranks are the most commonly used scores in norm reference interpretations. So norm reference interpretation, these are the advantages of norm reference interpretation. First, allows teacher to differentiate between students, corrects for assessment and or instructional error, easy for teachers to use, and consistently provides a standard distribution of scores. Disadvantages: promotes competition between students. Grade may be influenced by caliber of class or other students. Grades cannot be compared from one term to another. May not be fair to small classes. Difficult for students to monitor their progress in a course. May reduce the motivation of lower achieving students and does not provide information on students' mastery of course material. And these are the advantages of criterion reference interpretation. The first one, reduces competition among students, provides clear goal and set of expectations, useful for tasks requiring cooperation between students, promotes the use of specific measurable learning objectives, and students' grades not influenced by the quality of the class. The other one provides motivation for all students, generally preferred by students as they can easily monitor their own progress in the learning area, provides a consistent indicator of what students have learned from term to term, and selects students with a certain level of competence. Now, these are the common types of test norms. First is standard score norms. Name of derived score, standard scores. Meaning in terms of test performance. Distance of students' row score above or below the mean of the reference group in terms of standard deviation units. The second one is percentile norm. Percentile ranks, percentage of students in the reference group who fall below students' row scores. The third one is grade norms, grade equivalence, grade group in which students' row score is average. And that's the end of my presentation. Thank you for watching.